All right, so for the near pod today, we're going to go ahead and work through it, starting with the warm-up, which goes over 4 of the homework questions. So we want to evaluate log base 3 of 81. So we could rewrite that as 3 to the what power equals 81. All right, and 81 is 3 to the 4th, so when we write it so that they both have the same base, we know that x equals 4. So we know that log base 3 of 81 is 4. Okay, now what log base 6 of 1 equals what? So I'm saying 6 to the x equals 1. And so we know that the exponent has to be 0 here. Anything raised to the 0 is 1. All right, if you were looking to do it with the same base, 1 is 6 to the 0, and therefore we know that x has to be 0. Next one, log base 2 of 1/8, okay, equals what? And so again, remember a log is an exponent, so this x is the exponent. So 2 to the x equals 1/8. Okay, and so we know our properties of exponents, right? The reciprocal. So, and we know that 8's 2 cubed. So 1 over 2 cubed is 2 to the negative third. So 2 to the x equals 2 to the negative third. So x equals negative 3. And then 23. All right, so we go 5 to the what power equals negative 25. And hopefully you see that there's an issue here, all right, because that's negative. We can't, and that's positive. There's no way for that to happen. So that does not work. So no solution there. All right, so our objectives for today are to use properties to evaluate logarithmics, okay, and to translate logarithms into any base. All right, so quick review. All right, here's the definition. All right, the relationship between exponential form and logarithmic form. All right, so log base b of a equals x, right? This x is the exponent. So I like to say a log is an exponent, right? The log equals the exponent. The base should make sense, right? It's the base of the exponential, and it's the base of the log. Log base b of a, the a was the answer, the value of that power. All right. So we solved this rule the other day, right? Log base b of b to the x equals x. So just think about it. If you just rewrite this, right? If we're rewriting this, right? B to the x, right? And this is in parentheses, right? That's going to equal b to the x, which is a true statement. All right. So if that base is the same as that base, then the log is just going to equal whatever that exponent is. So right here, right, these 5's are the same. So this answer is just going to be 4. All right. So evaluate without a calculator. So this is saying, whoops, max. Log base 4 of 8 equals what? This is saying 4 to the what power equals 8. All right, and so we know 4 to the first is 4, 4 squared is 16, so this is going to be a fraction somewhere between 1 and 2. All right, so how do we figure that out? Okay, well, we want to get to the same base, and all the other ones it was pretty easy to write as the same base, right? This one always changed that base. But here I'm going to have to change both of them. Okay, I can change both of these to base 2. So 4 is 2 squared, right? And 8 is 2 cubed. So we know that power to the power, this is just saying 2 to the 2x equals 2 cubed. And so now we know our exponents. Okay, since the bases are the same, exponents must be equal, and then we can solve for x. So x equals 3/2, 1.5 if you like decimals. So we want to change the base, okay, if possible, so that the bases are the same. And that leads us to our change of base formula. We could rewrite any log, okay, using any base. All right, we'll take a look at what I mean by that. So that last one, log base 4 of 8, right? What did we do on both of those? We changed both bases to 2. So watch what we're going to do here. We're going to change it to base 2. So log base 4 of 8 is the same thing as log base 2 of 8 divided by log base 2 of 4. All right, and just think about that, right? Log base 2 of 8 we know is 3. And log base 2 of 4 we know is 2. We come back here, what was that last step that we did, right? We divided 3 divided by 2, right? So we see the connection there, right? And we could use any base, right? We don't have to use base 2, okay? We can make it any base that we want. And so we could rewrite any log, okay? Something that we don't know off the top of our head, like all the ones we've done so far yesterday and the warm up today, and we could change it to a base. Right? Doesn't mean we're going to be able to change both numbers to a base that we always know, but okay, there is a base that our calculator does know. All right, so with the calculator's help, we can approximate any logarithmic expression. And so our calculator has 2 bases that it does. It does base 10, we call that the common log. And when you just see log on your calculator, you find that log button, log, that is automatically base 10. Okay, so that equals log base 10. All right, and the other button you're going to see on your calculator is natural log. Right, and that's natural log, and it's on your calculator as ln, and that's the same as log base e. All right, we just learned about the number e the other week when we talked about compounding continuously. So it's a very valuable number and works well with logarithms. All right, and so those buttons are on our calculator, so we could always change it. So for example, log base 4 of 22, right? I can't make 4 and 22 the same base, right? So I'm just going to choose base 10. So on my calculator, I'm going to go log 22 divided by log 4. Type that in your calculator. Log 22 is approximately 1.34. Log 4 is approximately 0.6021. Divide that up and you get approximately 2.297. Okay, if I use natural log instead of log, I get the same answer. Natural log of 22 is 3.091. Natural log of 4 is 1.38. Divide that, you still get 2.297. All right. So again, that's the change of base formula. Change of base formula. All right. So it's log base a of x over log base a of b. So b is the base. I like to say b base bottom. Okay, so that base is going to be on the bottom of the change of base formula. All right, so here's an example, log base 32 of 8. Okay, so using the change of base formula on our calculator, just log 8 over log 32. Remember the base to the bottom. Use our calculators, and we get 0.6. All right, this is one that we could have done without our calculators as well, because we could change both 8 and 32 to be base 2, right? Log base 2 of 8, log base 2 of 32. See how we could choose any base here, right? Why would 2 be a smart one to use? Because log base 2 of 8 is just 3, log base 2 of 32 is just 5, 3/5, which is 0.6. All right, so you guys will have a second in class to try this, so try that before you watch the video. And so with this problem here, I could use, again, base 10. I'm looking at this and I'm thinking I could do base 3 here. All right, I'm going to go log base 3 of 27 over log base 3 of 9. And so that's going to be 3 over 2, so 1.5. Again, you could just type that into your calculator too without the base 3's. Log 27 divided by log 9, and that's going to equal 1.5 on your calculator. Or you could use natural log, right? Natural log of 27 divided by natural log of 9. That'll also equal 1.5. All right, but notice like that log 9, log base, whatever base you chose, of 9 is always on the bottom because that's the base for bottom. All right, try this one now. So again, I'll just show one way for this one. And again, the easiest way for me is without a calculator, although for you it might be with the calculator. Log base 2 here. Log base 2 of 16 divided by log base 2 of 8. It's going to get me 4 over 3. So that's my answer, 4/3. All right, so we're doing these three here. All right, log of 39. So rewrite using the change of base formula. Well, this one I would not. Okay, so it's already base 10. So you should just type that straight into your calculator. But I don't know, if I do the change of base formula, log 39, over log 10, because the base is 10 here, right? The bottom is just 1. Right, so there'd be no point in even doing that. So we come over to our calculator. So I like to use Desmos. If you come over, get the keyboard up, hit this function button here, right? You have log button right there. So log of 39 equals 1.591. So that's our answer. It says to the nearest thousandth. All right, so again, thousandths is the third decimal, tenths, hundred thousandths. All right, then log base 5 is 61. So again, if I go log 61 divided by log 5, okay, what's that equal? So over here on Desmos, okay, log 61 divided by log 5, I get 2.54. And you guys may have noticed this button, this kind of defeats the purpose of the change of base formula. But calculators now allow you to pick whatever base you want. Not every calculator has that feature. Like if we were in the classroom, our school set of calculators does not have that feature. But Desmos does, right? You can see the same answer. So 2.554. And the last one, log base 6 of 1.947. So log, I forgot, what was it? 1.947 divided by log 6 gives me my answer of 0.372. Remember, rounding to the thousandth, so round up on this case. 0.382. I already forgot. Was that the answer? 372. All right, and again, I just typed in log 1.947 divided by log 6. All right, and there you go.